MS Ramaya University of Applied Sciences.
Good morning, students. Let us discuss about the calibration of a load cell using standard weights. This experiment aims at depicting the calibration of a load cell using standard weights. Calibration is necessary for verifying the correctness of a reading as obtained by a measuring instrument. Comparison between a known measurement, which is a standard, and the measurement as obtained by a measuring instrument. It is carried out for a new instrument, a repaired or a modified instrument, after the lapse of a specific time period, after a specific number of hours of usage of an instrument, and in other similar scenarios. Load cell is basically a transducer. It consists of a load indicator, standard weights, aluminium flat beam, and a strain gauge configuration with Wheatstone bridge electrical circuit. Load indicator indicates the applied load on a strain gauge configuration by amplification. There are 4 strain gauges which is located at top and bottom of the beam. 2 strain gauges located at top surface of the object and other 2 at bottom. Accuracy of the load cell depend on applications and usage. Generally, depending on load cell type, accuracies vary from 0.03 to 1%. Laboratory load cell gives accuracy of 1%. A load cell is a device that is used to measure weight or force in a number of different applications. A load cell usually consists of 4 strain gauges in a Wheatstone bridge configuration. 2 strain gauges are mounted on top and 2 at the bottom of the object. By the application of load, resistance change in the object will be measured by using Wheatstone bridge electrical circuit. If strain gauge are under tension, then resistance goes up, and if strain gauges are under compression, the resistance goes down. Here, a load cell is a transducer which is used to convert a mechanical force, that is load, into electrical signal. This signal is usually in millivolts and requires amplification before it can be used. For amplification, analog to digital converter ADC will be used. Based on the applications needed, different types of load cells are available. Some of those load cells are as follows: S-type, shear type, beam type, container type, and bottom type. In laboratory, beam type load cell will be used to measure the weight or force. The apparatus required to conduct the load cell experiment are load indicator, load cell device, standard weights, and Wheatstone bridge with strain gauge configuration. The procedure for carrying out this experiment is as follows. Switch on the equipment. Set the load or force indicator to 0. Place the weights on the load cell. Note down the load indicated by load indicator. Compute the percentage error from the actual load and indicated load readings. Draw the graph of actual load versus indicated load readings. Load cell capacity equal to 10 kg. The readings obtained from the experiment must be tabulated in the format of a tabular column. Carry out the calculations using standard formulae of reading a load cell and find the error in reading as well as the sensitivity value of the instrument. One graph to be plotted after tabulating the readings in the tabular column. Indicated load versus actual load of load cell readings. This experiment has its own benefits and limitations. Benefits of the experiment. Product liability and safety issues demand that force measurements are demonstrably accurate, which is usually achieved by calibration to national standards using load cells. Load cells are fundamental importance to many industrial sectors including aerospace, marine, heavy lifting, and automotive. Limitations of the experiment. Load cells become less reliable due to electrical impact and mechanical effects. Calibration of all load cells at regular intervals should be carried out due to deterioration, mistreatment, and drift or aging.
Hi students, title of the experiment is Calibration of Load Cell. Aim of the experiment is we are going to calibrate the load cells by using standard weights. Operators required for conducting the experiment is load cell equipment. Calibration of a load cell consists of load indicator, mains on, console on, strain gauge technology. The load indicator, it is going to indicate actual load applied on the strain gauge in kilograms. The mains on it indicates that mains power supply. The console on it is going to we are going to switch on the load indicator display. Strain gauge technology. The strain gauge arrangement consists of strain gauge, V-stone bridge and aluminium beam. So the purpose of using strain gauge is when you apply the load, we are going to measure this strain value. Here we are going to measure the deformations. So when the V-stone bridge electrical circuit, we are going to use in the load cell to measure the change in the resistance of the object when you apply the load on the bar. And standard weights. You are using the standard weights on this strain gauge arrangement to measure the actual load versus indicated load and to find out the percentage error. Now let us start the experiment. Switch on the main power supply, that indicates that mains on, it is switched on. The next is you are going to switch on the console on, that indicates that the display of the load indicator, it's going to show, that means we are going to calibrate it that it is a 0 value. Next we are going to apply we are going to put the different load on the strain gauge arrangement to find out the actual loaders versus indicated loader, whatever you are getting from the load cell, and we are going to find the percentage error of the actual load versus indicated load. Now we will try different combination of the load. We are going to place it on the load cell. Now I am going to place a 1 kg of a weight on the load cell arrangement. Then we are going to see that what is the actual load we placed on the strain gauge and what is the actual indicated load we are getting from the load cells. Now we can see the 1 kg of weight we placed on the load cell, and we are getting 0.99 kg is a indicated load. So that indicates that 0.01 kg is an error. These kind of error may come according to with respect to the mechanical impact or electrical effects and the improper handling of the equipment. Now I will try with another different combination of weight. I am going to use 0.5 kg. Then I am going to remove the 1 kg from the earlier one. I am going to place the 0.5 kg in the load cell. Then what is the value we are getting from the load cell, we will see now. Now 0.5 kg I placed in the load cell arrangement. The indicated value is 0.49, means kg. The 0.01 kg is an error. The error it is here, that remains constant in this particular trials. So like this we can try different combination of the application of the load on the load cell and find out the percentage of error. So load cells you can see, you would have seen in the weighing machine, weighing bridge and provision stores. So you can find different applications across the different areas. So it concludes the load cell experiment.
At MSR UAS, we spark your imagination unlike any other.